Hi everybody, my name is Lionel Erco, and today with my colleague Rob, we are going to talk about the state of the union of DC networking automation and what we are doing at Cisco to drive the automation for that. So we're first going to talk about our Cisco infrastructure as code strategy, what we think people should be looking for and kind of the driving factor there. Then Rob will take over and talk about the Nexus as code project, how to bootstrap your automation for our data center networking solutions, and then we'll come back and talk about application derivative changes and how we can take events and drive your network infrastructure directly from other system sources. So let's start with the Cisco infrastructure as code strategy. So the main word here is choice. It's giving choice to customers between tool sets, platforms, and systems and products that you can automate. If you have looked at our third-party automation capabilities in Ansible, Terraform, a large variety of our products are now supported. We give you the ability to use most of the products that Cisco offers, either in Ansible or Terraform or Python or SDKs and the rest. We also allow you to run in different platforms, Intersite, Nexus dashboards, and the rest. The idea here is to give you the choice. Now, talking about choice, we also think that there is different user experience that people want when they try to look at automation. The first pillar of our strategy of development is to give you that choice in terms of Ansible collections for our different products, on Terraform providers. But from there, we think that we need to build on top of it. We need to be able to build roles or modules to give you easier, larger blocks, reusable blocks, like Lego blocks that you can build from one on top of the other. That's the middle layer there. But then on top of that, what's your user input? How do you want as a user to interact with this automation? And most of the people, when they start, they either write the code directly in Ansible or in Terraform, but very quickly they realize that most of the logic is going to be in data manipulation. You take some kind of a data model, and from that data model, you drive the configuration. It's kind of inventory-driven configuration. It's really the way we see things are evolving. And that's where those data sources, either being YAML, JSON, maybe even CSV and Excel, as the data source for driving the rest of your automation. This leads directly to Nexus as code, and I'm going to leave Rob to talk about Nexus as code.
I wanted to introduce Nexus as code to you. So we published this actually a few months ago. So it's an open source project driving automation in data center networking infrastructure through an inventory-driven approach, right? So this becomes much easier for people that are familiar with, the operating or the operating system or controller that they're interfacing with, without having to understand the domain-specific language that's sometimes involved when you work natively with Terraform, with HCL, or through Ansible. So Nexus code is really an example, one of the first examples that we have around inventory-driven automation, which should lower the barrier of entry for people to start automating their data center networking. So initially we made this available for ACI, and we're currently looking at where we expand this going forward. So the idea is that on the left side here, you can see that inventory approach. So there's no logic there, there's no loops, there are no references, it's just an inventory structured in a YAML format, right? So that's what the user interacts with. Now, this is an example of a slice of infrastructure in an ACI fabric. So you have a tenant, you have your verb, there's a couple of bridge domains. Again, a human readable and also machine readable definition file without needing to understand, domain specific languages, right? So what you see here is that if you put this in front of someone that has worked with an ACI solution through its GUI before, this will make sense to them, right? They understand there are bridge domains, there's a subnet definition. So that's really there to drive the simplicity and an additional layer of abstraction on top of the tooling that we already provide for some years. So the way it works is, the difference between Terraform and the inventory-driven approach is interesting to take a look at, right? So if you look at the model on the left, this is HCL. So that's a Terraform plan. And what you see here is there is actually a definition of a variable with two verbs in there. And then we basically create a resource that loops through those variables and then creates those resources. Now we find that sometimes this adds an additional level of complexity for network engineers that just want to create resources. So if you look at the inventory model on the right, there's no need to think about loops and references. You just fill in the inventory in that YAML format and drive your changes through that way. So there's the majority of what we've done is actually consolidated in a way that feels very familiar to those that have worked with the GUI, as I mentioned. Now there are some exceptions because in the GUI, from an ACI perspective, we realized that some of the elements are a bit dispersed. So for example, if you register a leaf switch, something sits under the inventory in Fabric Management, but then if you look at the management IP address, it sits in the management tenant. So where it made sense, we have consolidated those resources together so that everything that concerns a specific function in the Fabric is actually grouped together in a specific inventory definition. So we continue. I just want to sit down and actually show you live an example of how that works. And then I'll build on top of that with some additional tooling that we have recently open sourced and bring that all together in a pipeline. All right, let's see. We're still logged into the ACI Fabric. We should be, yes. So what you see on the left-hand side is the result of a Git clone of a repository that we have made accessible for everyone. So those that want to experiment with it, they can access these repositories. Everything is public domain. In fact, the whole site where we have published all this documentation and Git repositories is the Nexus code page. So for those that want to visit, it's cisco.com/go/Nexus code, and you'll be able to find it. So on the left-hand side, we have this inventory, right? So there's a tenant name, a verb, and a couple of bridge domains. Nothing too fancy. So it's just about, how do we use this to drive infrastructure changes? So we'll just move this out of the way a little bit. And the only interaction we have with Terraform is basically this pre-built plan that contains my user credentials. And I'll get into the details as to how we pass the inventory actually through the Terraform module. So we discover that in just a bit. So if I run a Terraform apply here, it's asking us to create 15 resources. So once we're satisfied with that, we can go ahead and write yes. And that should create that new tenant in the infrastructure. And I found that, when talking to customers about this, this is much simpler to understand, in terms of inventory, and then they directly see the changes happening in the infrastructure. So we go down here a little bit. I should have my tenant. If I refresh, TFD, tech field day, and the resources that we see in this inventory file that is in the data folder, you can see that there is a couple of resources that got created, right? So these are basically the equivalent of what we see on the left, right? So that's how we interact with it. So it becomes very simple to start adding new resources. So for example, if I want to add another bridge domain, I could just take this block, paste it into this inventory file, save it. Of course, I might want to change the octet so there's no overlap. So I'll just change the octets over here, and then I'll run Terraform apply. And in this case, it will tell me to add 3 new resources, which is the subnet, the bridge domain, and a relation to the verb. So I'll write yes. And now I should have that new bridge domain as soon as I refresh the GUI. Right, so that's quite simple, right? Because you understand at least, the subnet, the IP address that's there. But what if I want to do something that's not already in that repository? Where do I go? Where do I find resources? And we have actually made the whole data model available for the objects that we have in ACI on the Nexus code page. So I'll be showing that right now. So if you open the Nexus code page, there's a section for data model. And over here, we can take a look at, for example, the module for tenants. So this contains all of the configuration that I might want to do in a tenant. There will be one for node profiles, there will be one for access policies. So there's these different top-level Nexus code modules that we're using to pass the inventory information to the right resources to drive the changes in the infrastructure. So if you look at this model, we started by location in the GUI, right? Which is where users have familiarity. They understand, okay, I have a tenant, in there I have a name, then networking, and then different resources. And then what we're doing is we're also showing the diagram, so the object model itself and all the relations and classes that are in there just for reference. And then below that, we have a list of attributes that we can use for these classes. So for example, a bridge domain needs a name, right? And we also show you that it's a type string and whether there are any constraints for that specific field, and also if it's mandatory and if there's a default value. So touch upon the default values in just a bit as well, because we've taken some of the best practices surrounding these default values and incorporated those in the code and the default values that we've shipped. So for example, if you want to make a change and you want to enable host route advertisement on a bridge domain, you could just take this attribute. You would be able to paste that in your code, and then the expected values are true or false. So what you can do is go to that specific bridge domain and you add another line here, advertise host routes, and then you say true, right? And in that case, we'll change the existing resource in place. So we'll update that bridge domain to reflect that new change. So if you would open that bridge domain, which was 201, we see that host route advertisement has now been enabled, right? So it's quite simple to figure out, how they relate to objects in the GUI, and they're all documented on the data model page. So that's it for the simple example. So for users that want to follow along at home, you can go to the page and there is a simple example section, which you can find, if I just expand this again, under ACI, under simple example, and everything that I just did to get familiar with pushing your initial tenant can be found here, prescriptive and step-by-step. So let me just head back to the slides and explain a bit of the theory behind it. All right, so this is actually how we pass the inventory information to the modules. So what we do is we merge a range of YAML files that you find in a specific path and demerge them together so that we can pass the right objects and resources to the specific modules underneath. Right, so for example, what you're looking at here is the inventory, and then what we see here is actually the content in the Terraform plan that passes that configuration. Right, so what we're doing here is we're reading in the apic.yaml, which is this file, and then we're passing for each value found for tenant name to this specific module for tenant containing all the configuration that I just pointed you in the data model. So that's all the interaction you really need to do with Terraform, is basically passing these inventory informations to the different modules that exist. So the modules that we have are grouped in 6 categories, and underneath these high-level modules that you see over here, this is a Nexus code module. So what you have here is the tenant module, and underneath we have defined smaller modules which you don't interface with directly, which contain the lower level functions. So for example, there's one for a bridge domain that we just touched upon, and these are all grouped together in these high-level modules. So there's 6 of those that we have in total. Then in terms of the YAML layout, right, we just worked with one file, but what if I have an entire team that works on different parts of the infrastructure? Can I structure this in a way that makes sense for my business requirements? And the answer is yes. So this is an example of how you could do it, where again, it makes sense to people that have worked with ACI before in terms of structure, right? So if I were to replace my node 101, well, where would I go? Probably to that file to change those settings. If I wanted to consolidate everything in a single file, I could do that. If I don't want to do it and I have, for example, a tenant prod and I want to split that out in 5 different teams that make use of that configuration, we also do it. The small detail to keep in mind there is that if you spread the state, for a tenant across different, Terraform workspaces, we've added an additional flag that sets managed to false. And if you set managed to false under the tenant, we will never throw away the tenant, right? So that's something to kind of protect yourself from another user throwing away that configuration. The data model I already discussed. So this is really where you should go if you want additional detail on which are the attributes that you can actually use, the constraints and the default values. The default values come with the modules. So all of the 6 modules have default values included. And these values, they actually come from best practices and design white papers around configuration settings, and we've incorporated those into the code. You can override these settings for your environment. And the benefit of that is that if you have, for example, a specific requirement in your organization where you always want to prefix or suffix certain resources, for example, if you create a bridge domain and you want to add _BD, you can actually do that by just adding a default file, and in there you can add a name suffix as an example. Or if you have a layer 2 fabric, because you don't do any routing, maybe you want to set unicast routing to false for all of the bridge domains that you create going forward. Now, if you have a local bridge domain definition over here, you could still go ahead and override that default value on a per resource level, right? So this is the flexibility with the default values. And also the benefit of that is that you don't need to add all of these default values each time for the specific resources that you create. So it creates a much cleaner inventory file. I'll now be showing a couple of tools that we have also open sourced as part of this project that will improve the quality of the code and also the pipeline that we're doing. So what I'm about to show is also listed on the site, so it's spread in different sections. So there's a validation section, which will cover some of these elements, and a CI/CD section, which will help you build a pipeline so that you can start working on the infrastructure as a team. So here we have a couple of tests, and we're going to do linting, semantic and syntactical validation. And also we're going to do some additional checks. So here we have that same inventory file, but the difference now is that we're not doing everything locally from our machine. We're actually using a version control system to basically, store our transactions centrally. So what we're doing is we're staging our change and we're pushing the updated files to our repository. I'm working in master branch. Typically, you would work with different branches and then do mergers, but for the demo, I'm just working in master. And here you can see that these steps that we defined in a pipeline are actually happening sequentially. And here we have the first open source tool. So that's a tool called IaC Validate. And what it allows the user to do is define their own checks that they want to do on the infrastructure. So for example, if they have, in this case, we're hitting a rule 104 where there's subnet overlap. Now, how does it know that there's subnet overlap? So we give the user the flexibility to write in Python their own checks that they want to do on the code, and then we validate the inventory against those rules. So here we have that Python file, which we give a couple of examples with so that you can get started with writing your own checks. So this is, again, available as is. And that will allow us to at least correct the change. The other element that's important is the schema validation. So here you can define your own requirements, saying I always want a subnet when you configure a bridge domain, otherwise I want you to fail. Or I always want you to follow this naming structure. So we validate against the schema when you push the changes. Now, we're also, in this case, sending a nice notification to WebEx. So we discuss how this can be integrated with chat clients, for example, to get some information about what fails. So we just parse the output basically from the pipeline and send a nice message that probably the change was unsuccessful and we need to correct something. So let's go ahead and go back to the code and actually fix the bridge domain configuration. And those that paid attention will probably have noticed that there was subnet overlap. And here you can see that there's a different octet that we're using. We're again, committing the change, we're pushing the change to the Git repository and triggering the whole pipeline again. And the validation should succeed, right? So this has nothing to do with any commercial solutions that we have. It's an open source check where you define, which rules you want to apply against those inventory files. So here we can go ahead and deploy. Which is just the Terraform apply action that happens underwater. So the config gets pushed to the target. And then after that, we have a test integration that we do. So for the resources that we push, we've basically made some robot tests available so that for the resources that we push, we actually read APIC and ask for the health score of the resources that we provisioned. ACI is very nice in that sense. It will tell us exactly if there's any anomalies and the health score will be great. So if the health score is not 100, we can expect that the change has failed and we will report that the whole pipeline has failed instead. So here we can see those resources basically being provisioned. And I'll zoom in just a little bit in the video. And it's basically, again, a reflection from the left. But now, you make sure that at least you validate the input and it's correct and what you expect from a configuration standpoint. So that's all good. But can't I apply a bit more reasoning to it? And for that, we do have a solution. So those familiar with Nexus dashboard, there's a service that sits on top of that lets us do pre-change validation, right? So it has hundreds of checks built in. And we could actually ask Nexus Dashboard Insights to validate our proposed change combined with the current state of the infrastructure, right? So if I go to the next video. So here we're in Nexus Dashboard Insights. So the first thing that we're going to do is actually set up some compliancy and traffic restriction rules, which Nexus Dashboard Insights lets you do. So we're going to set up our first requirement. So in this case, it's a configuration requirement that we're going to set up. We always want a bridge domain in a specific site to adhere to the settings and configuration that we'd like. So in this case, we're going to go and select all the bridge domains that we're going to push to a specific, actually in this case in all tenants, and we're going to want ARP flooding to be enabled. And if it's not enabled, we want again to the pipeline or at least the process to fail. Right, so we set up a config requirement, but maybe more importantly, you can also set up communication requirements. From an SLA perspective, you always want resources to talk, or you don't want two specific resources to talk. Imagine you have, testing environment and production environment. You create a rule that says they should never talk with one another. Right, so here I'm selecting those tenants. And in this case, I can also be specific as to which type of traffic I don't like, but here I'm filtering all the traffic that we have. And if I go to my live setup where I did a demo, I have a compliance rule in place that says my new Cisco Live tenant should not be able to talk to the internet. So there should not be a contract to the L3 out that I have in place. And I can set that rule up by just, again, defining that must not talk to and selecting the Cisco Live tenant and comment. And what I have in my code over here is actually a default contract, which allows me to talk to the L3 out, so to the outside world exposed to the internet. So if I push this change, I want it to fail, right? So what we're doing as part of this process is in the PCV change, we're taking this input and we're layering that on top of the current running state of the infrastructure and then measuring whether there's any difference, from a fault perspective, incorporating this inventory change. So here you can see that there's a pipeline that got created. And if I expand that and go to the analysis, you can get a Venn diagram that shows you the delta between the current state, what's same in both states, and then what's seen only in the new state, right? Which is what you care about when you do pre-change validation. So what we can see here is that we're violating our own segmentation rule. So we want to abort this change and give that back to our pipeline. So what we're doing here is we can actually analyze it to get a bit more detail as to what it is that we're actually violating. Maybe we're not aware. So in this case, we're actually being pointed to the network segments that are now able to communicate and on which ports as well, right? So there's a lot more detail on what I'm getting out here. So this is something that you might want to do when you have a bunch of changes that all pass the validate stage. But if you're merging them together and want to push a config change to the ACI fabric, then maybe you want to do a pre-change validation as well. So with that, I am going to load the slides again and hand it back to Lionel to talk about application derivative changes.
Application derivative change is the idea that an application will change state in some way, and then we're going to use a detection mechanism to discover that change. Any service discovery, monitoring, anything of that sort. And then we are going to use some kind of notification between this discovery and a trigger to make a change to our infrastructure. And how are we going to make that change to the infrastructure? It's using automation, it's using infrastructure as code, it's using all of the things we just talked about. The first introduction of that comes from HashiCorp. It's called the Console Network Infrastructure Automation, and it uses Console as a service discovery tool and a health checker to know if a service works. When you have an update on the console catalog, automatically you can trigger a change to console Terraform sync, and console Terraform sync can then use Terraform to implement change in the infrastructure. Console Terraform sync is an open source binary which connects console to Terraform and take that state data from the application, from the service discovery, and make changes. So what we want to look at is, can we make these changes into our network infrastructure? Can we use the data from the network, from the application itself to drive the network configuration? Can we kind of remove that need of opening a ticket, making a ask to someone? Can we drive that directly? So that's really the idea behind this application derivative change system. Our use case for it is, we have two use cases. The main one is around microsegmentation. So you might have heard about ESG, endpoint security groups in ACI. This is kind of your security group if you have in the cloud, but you have that on your on-prem network fabric. And the big idea of this is that you can create group so that you can actually define access and who can talk to those groups. Not only who can talk to, but make sure that some people don't talk directly. For example, that the external user don't talk directly to your database, but can talk only HTTP to your web server. Now, the problem with this kind of configuration is that every time you add a web server, you have to go and update the database. You have to update the configuration to know that there is a new database. Now, if that web server is a console agent, you cannot drive this through that change because console will detect a new member and it will go and grow. Now, it's not only a grow, because console will also give you a notification if something goes down. So you can then revert and go back to your previous definition. So you can grow, shrink, delete configuration. So this is what I'm going to show you in the demonstration. So let's have a quick look at that. So let's start with console Terraform sync. So console Terraform sync has a file, a configuration file where you define which Terraform provider you use, how often do you want it to pull, and you define a task. The task is where you define a Terraform module that's going to be used by the systems to trigger a change. In this case, the module that we are using is called ESG and IaC. And so it's a very simple module. What it does, it gets some information about the tenant and the application profile, and then it automatically creates the resources based on the data that's streamed through. So when I make a change, when I'm going to start the system, I'm going to get this information that shows up. So the first thing I want to do, let me just start my console container. Sorry, just give me 1 second. So I'm going to start my console server. Give me 1 sec. I'm just going to jump.
I don't believe it's happening.
Yes. Where's my RM? Sorry. Yes. Okay. So I already have it starting. Let me see, where is my console element? If not, I will jump. Yes. Oops. Sorry about that. Let me actually use this video, and then because I want to do it live, but you know, always creating some issue. So in this issue, so we can start with the APEC element, and in APEC you can see that we don't have any endpoint groups. We don't have anything available here. Once we go in console, you can see that console doesn't have any service, anything that's running, anything that we can see configured. Now I'm going to start the first container, and the first container is going to come up in console, and then you're going to see that the first container, when it comes up in console, is going to be starting, and then console is going to run the health check and see that the health is not correct. Now I'm going to start the Nginx service on that, and then the probe is going to determine that it's an active service, and at that point, you're going to see that the active service comes up. Yeah, so when the active service comes up, then it automatically triggers in Terraform, and in this case we are using Terraform Cloud to make the changes to the infrastructure. It triggers a plan to be queued. The plan will get a plan, then it's going to get approved. It's going to run the planning phase, then the applying phase, and it's going to make a change to our infrastructure. When it's done, we're going to jump into APEC, and in APEC we can see that now we automatically created the endpoint service group, security group, and then we assign this container directly to this service group. Now, what we're going to do is we're going to start, you can see that the IP corresponds to the two. Now, what we're going to do is we're going to do a second one. Let's do another container. Let's pop up another container. Let's power it up. It goes through the phase. I speed this up, and then it appears automatically in APEC.
So the health check you're performing is on port 80.
So the health check is performed by console, and it can be any definition that console supports. So console support layer 7 definition. So you can do you can pull the API and check a response. You can do as much as you want. And that's one of the advantage, because in the switch infrastructure, we don't necessarily have those layer 7 checks that we can do for health probing. You can do an IP SLA, you can do those things, but you can't necessarily check a response code from an HTTP API. Console can, and then console tell the infrastructure, that something is done, and we can then modify our policy.
Okay, so it means that then when you're developing a proof, then you can ask for specific things within the header. Maybe you would be looking for a code 200, okay, and these type of things, right? Okay, good.
Exactly, yes. And those checks are not embedded in this automation code. It's defined by the console agent that's attached to the application. So when the developer develops this application, he knows what's a good application health status and a bad application health status. So he does that to give us this information. So you can see now that we have those two developed there, but that's not the only case. Is what happened, because most of the time people have no issue to push configuration. But what happens if something goes down? What if the service starts to not work anymore? Or if I start retiring services I don't use anymore? And that's the beauty here, is because of Terraform, Terraform knows what it created. And so if, for example, one of the service disappears, now automatically the system will trigger again a change, and this change will automatically remove this element from the configuration in your network infrastructure, in this case in Epic. But not only that, if we remove the second service, it not only removes this entry of the IP addresses, it cleans up completely the service group.
Because what's a threshold to determine that you would be able to remove the entire service and not that for some reason you just lost the momentaneous reachability to the application?
So
could you trigger a complete removal when actually it just went down because it was, I don't know, rebooting something?
Yes.
Just make an example.
So in that case, this is something you would have to do on the probe side, and you can actually tell console that it can wait a certain time. But so yeah, that part is part of the console and the element. The whole console Terraform sync is an open source project driven by Ansible. The part here is to show you how you can use that in your network infrastructure, which people don't necessarily think about. People think more about cloud, they think more about your application element, but here we talk about on-prem data center networking gear that's actually behaving like a cloud. It's reactive to events and
it's fitting more the, let's say, developer mindset. I don't need it, I just destroy it, yeah. And then often you have these fragments in the network configuration that are staying and so on, so you bring both together.
It does help. In most cases, you find a random ACL in when it's legacy that it's sitting somewhere with some source IP address doesn't exist anymore. Probably the VLAN doesn't even exist anymore, but they had something deployed for testing and never removed it. So it's good. Well, I find it quite cool, especially when you keep doing this type of tests in the data center, for instance, or even the cloud, whatever. The gotcha then, it's not about the way it works or the way the updates happen, but how do you then tune the trigger correctly so you don't then cause a false positive there? Do you remove things that you actually didn't have to remove? But that's then what happens in the console. It doesn't happen actually within ACI. Okay.
Yeah.
It's all about the trigger. Thank you.
Yes. And actually, so this is one of the use cases we are driving on the microsegmentation capabilities. But then there's a second use case we have published also, which is around policy-based redirect. So our ACI fabric can redirect traffic between any two endpoints to a third party. So you can redirect to a firewall, load balancer, or any type of inspection device. We actually can do the same membership redirection or the same membership dynamic membership element with those. So we could, if you grow, for example, if you redirect to a load balancer, that's a dynamic load balancer, maybe containers or VMs, we can also grow that pool automatically with the same ID. So both of those things have been published on the HashiCorp registry as modules for you to try. So you can scale that load balancing, that fabric policy-based redirect, or this one.
Is this an equivalent of a service graph?
Yes, correct. So in the service graph, you have what we call a policy redirection or a redirect policy. And in that redirect policy, you define where you redirect. And that membership, you can actually grow it based on triggers by console.
No, that's perfect. I just wanted to draw the parallels so you could see where it comes from, because otherwise then the naming could change at some point.
I have one question to that.
Yeah.
So with the Terraform, and so it's more, let's say, switch perspective from network to dev perspective, yeah?
Yep.
They want to do this, and it's nice that this is all working with Nexus, and I also like that you simplify this for entry level, but in Cisco world, then you have a catalyst switch, or you have an FTD firewall, or a Viptela device, and always the dev guys don't like that the interfaces to access those are different, yeah? Different APIs and so on. Do you know, is somebody working on such a thing for other products as well?
But so the beauty of this concept is the infrastructure there can be any infrastructure that has a Terraform provider.
Sure.
So the one you mentioned, FTD as a Terraform provider, IaC as a Terraform provider. So if you use those, I can take the exact same demo tomorrow and do it for FTD, for Terraform, for IaC or the rest. Because that's the beauty of something like Terraform or Ansible. It provides you that layer of abstraction across Cisco product, but technically across third parties too. So this is really the idea here, is that you can do that across the whole Cisco portfolio if there is a Terraform provider for that product.
Sure, with the console thing, but with the Nexus on code, I like the simplification and the starting point, yeah? Now, if I want to do, let's say, a similar configuration, let's start simple. I change NTP to all these devices thing, then I have to figure out this for all these modules, yeah?
Correct. So this is something, so right now, it's on ACI and we're extending to the rest of the data center networking capabilities, and then we can see further to grow it. Also, it's an open source project, so contributions are welcome from the community to go there and add for that.
So for you, Nexus was a starting point, but could be that you add, I don't know, something else to your portfolio, yeah?
So I think I'm still on video, so I'll just stand next to Lino. So, I mean, the question is, why can't we all work happily together, right? It's a good question. And, there's standardization that happens, at least from an API perspective across the portfolio. So I think that's step one going forward that we're, trying to achieve. Specifically as it relates to the inventory approach with Terraform as code, or Nexus as code, I should say, is that, we really look for feedback here, right? So if you're listening to this and you think, hey, that's actually relevant, we'd love to see this for product XYZ within Cisco, I mean, let us know, right? I mean, we're part of the team responsible for Nexus, but, our counterparts are, definitely also interested in, making it as simple as possible to consume the API of their platform. So feedback is very welcome.
Yeah, at the end of the day, we have similar functions, an interface to create something, but we have very different APIs at the moment, yeah?
Yeah, but we are trying to drive to consolidate those and trying to make them, first, all the API look similar. That's an initiative that DevNet is doing, into having guidelines for every new API that they are similar, and then growing to having a really similar interaction with third-party things. Okay, so one of the things I wanted to mention is, because we saw this console Terraform thing with console, and the idea is to take state of application, which could technically take from everywhere. But what if we want to push this even further? What's the next things we are looking into? And one of the things is that you can push this concept one step further and removing application completely from it and generalizing from any change to any database that can have a trigger mechanism into the infrastructure. So this is really the idea of taking not only changes from application, but maybe from tools you already use. You might be using a CMDB or a tool like Netbox or others to do. So one of the things, and we don't have the time to do it today, but it will be in Cisco Live in the hub and online. We have a demonstration on how to use this with Netbox as a source of data to drive change directly into ACI. I will be presenting that tomorrow. So just wanted to let you with this idea that think about the way you want to drive your configuration from any source of data so that you don't necessarily have to do that manually.